Hello all, my name is Sheikh Mohammed Iqbal and I am from C2 CSCD. My registration number is 21BQ1805L0. Today I am going to give a seminar in CO and my topic is addressing modes. So let's dive into my topic. Addressing modes. The term addressing modes refers to the way in which the operand and instruction is specified. The addressing mode specifies a rules for interpreting or modifying the address field of the instruction before the operand is actually executed. Addressing modes for the divided into two categories: addressing modes for data, addressing modes for branch. So let us discuss both of them. The 8086 memory addressing modes provide flexible access to memories, allowing to the easily access variables, arrays, records, and other complex types. The key to good assembly language program is the proper usage of memory addressing nodes. An assembly language instruction consists of two parts: opcode and operand. The memory address of an operand consists of two components: important terms. Starting address of a memory segment, effective address of a offset. An offset is determined by adding a combination of three addresses elements: displacement, base, and index. Displacement. It is an 8-bit or 16-bit immediate value given by the instruction. Base. Content of the base register BX or BB. It is denoted by BX or BB. Index. Content of the index register is SI or DI. According to the different ways of specifying an operand by 8086 microprocessor, different addressing nodes are used by 8086. Addressing nodes used by 8086 microprocessor discussed below. Implied mode. In an implied addressing mode, the operand is specified in the instruction itself. In this mode, the data is 8 bits or 16 bits long data. It is a part of instruction. Zero addressing instruction are designed with implied addressing mode. So see how it works. Here, before I have addressed what is in addressing nodes and types of addressing nodes. So see what are the types of addressing nodes. Implied inflicting addressing node, stack addressing node, immediate addressing node, direct addressing node, indirect addressing node, register direct addressing node, register indirect addressing node, relative addressing node, indexed addressing node, base register addressing node, auto increment addressing node, auto decrement addressing node. There are total of 12. So we have discussed about what are addressing nodes and types of addressing nodes. So let us move to the types of addressing nodes individually. Implied addressing nodes. In this addressing mode, this definition of the instruction itself specifies the operand implicitly. It is also called as implicit addressing node. Example, the instruction complement accumulator is an implied mode instruction. In a stack organized computer, zero address instructions are implicit mode instructions, since the operands are always implied to present on the top of the stack. See, let us see an example for this. Here example, CLC use it to reset the carry flag to 0. See here instruction data. The example for the data is presented in address and it is used to hash. It is used by hash. Here we can see. In this mode is a present in address field of instruction desired like one address instruction format. Note, limitation in this implication mode is the range of constants are restricted by size addressing field. So let us see. Immediate addressing mode. In this addressing mode, the operand is specified in the instruction explicitly. Instead of address field, an operand field is present that contains the operand. Your opcode operand, immediate addressing mode. Examples: add 10 will increment the value stored in the accumulator by 10. Move or hash 20 initializes register R to a constant value. So let us see the next one. Register mode. Before going to register mode here, it is not important, but let us discuss stack addressing mode. In this addressing mode, the operand is contained at the top of the stack. Example, add. This instruction simply pops out two symbols contained at the top of the stack. The addition of two components is performed. The result so obtained after addition is pushed again to at the top of the stack. So let us move to the next. Direct addressing mode. In this direct addressing mode, the address field of the instruction contains the effective address of the operand. Only one reference to memory is required to fetch the operand. It is also called absolute addressing mode. Here we can see opcode A is directly connected to the operand in the memory, direct addressing mode. Here an example, add X will increment the value stored in the accumulator by the value stored at memory location. accumulator plus square brackets x. Here square bracket x denotes to the value in the location of the x. If we take 100, it goes to register 100th memory and fetches the data in the location of the 100th memory. Move the contents of CX register to AX register. Sorry, direct and addressing modes. So let us move to the, see here, we can see effective address data. Example, add AL, 0310. Add the contents of the offset address 030 to A1 AL. Next addressing node. Indirect addressing mode. In this addressing mode, the address field of the instruction specifies the address of memory location that contains the effective address of the operand. Two references to memory are required to fetch the operand. Opcode A to the points to the effective address, and effective address again fetches represent to the operand. Example, add x will increment the value stored in the accumulator by the value stored at memory location specified by x. Accumulator is equals to accumulator plus double bracket of x. Register director addressing mode. In this addressing mode, the operand contained in a register set, the address field of the instruction refers to a CPU register that contains the operand. To the reference or to memory is required to fetch the operand. Opcode of OR. Here, the block diagram of the register direct addressing mode. Example, add R will increment the value stored in the accumulator by the content of register R. Note, it is interesting to note this addressing mode is similar to director addressing mode. The only difference is addressing field of the instruction refers to the CPU register instead of main memory. Next, register indirect addressing mode. In this addressing mode, the addressing field of the instruction refers to the CPU register that contains the effective address of the operand. Only one reference to memory is required to fetch the operand. The block diagram of the register indirect addressing mode is here. Here we have opcode and OR. This OR represents the effective address of the register set. These effective address value with directory represent the operand in the memory. Example, add R will increment the value stored in the accumulator by the content of memory location specified in register R. Accumulator is equal to accumulator plus double bracket of R. Note, this addressing node is similar to the indirect addressing mode. The only difference is addressing field of the instruction refers to the CPU register. Relative addressing mode. In this addressing mode, effective address of the operand is obtained by adding the content of the program counter with the address part of the instruction. Effective address is equal to content of the program plus address part of the instruction. This is a block diagram of relative addressing mode. See here, operating code A plus memory operand. Both adds to the PC and PC is added to the operand. Program counter always contains the address of the next instruction to be executed. After fetching the address of the instruction, the value of the program counter immediately increases. The value increases irrespective of whether the fetched instruction has completely executed or not. Indexed addressing mode. In this addressing mode, effective address of the operand is obtained by adding the contents of the index register with the address part of the instruction. Effective address is equals to content of the index register plus address part of the instruction. Opcode index register A. Here is a block diagram of the index addressing register. Base register addressing mode. Effective address of the operand is obtained by adding the content of base register with the address part of the instruction. Here effective address is equals to contents of the base register plus address part of the instruction. Here is a block diagram of base register addressing mode. Next we move to the auto increment addressing mode. This addressing mode is a special case of register indirecting addressing mode, where effective address of the operand is equals to contents of the register. After accessing the operand, the content of the register is automatically incremented by step size D. Step size D depends on the size of the operand accessed. Only one reference to the memory is required to fetch the operand. It is a block diagram of the auto increment addressing mode. Assume operand size is equal to 2 bytes. After fetching the operand 6p, the instruction of a register R auto will be automatically incremented by 2. Then updated value of R auto will be 3320 plus 2 is equal to 3302. At memory address 3302, the next operand will be found. Note, first the operand value is fetched, then the instruction register R auto value is incremented by size D. Auto decrement addressing mode. The addressing mode is again a specified case of register indirecting addressing mode, where effective address of the operand is equals to content of register minus step size. In the first addressing mode, first the content of the register is decremented by step size D. Step size D depends on the size of the operators accessed. After decrement, the operand is read. Only one reference to memory is required to fetch the operand. Example, here is a block diagram which represents the auto decrement register. Assume that the operand size is 2 bytes. First, the instruction register R auto will be decremented by 2, then the updated value R auto will be 3302 minus 2, 3300. At the memory address 3300, the operand will be found. Note, in auto decrement addressing mode, first the instruction register R auto value will be decremented by step size D. Then the operand of values will be fetched. Applications of the addressing modes. Immediate addressing modes to initialize the registers with a constant value. Direct addressing and register direct addressing mode to access static data to implement variables. The advantages of the applications which are used for the indirect addressing mode and register indirect addressing mode are to implement pointers, because pointers are memory locations that store the address of another variable. To pass array as a parameter, because array name is the base address and pointer is needed to point the address. Relative addressing mode and its application for program relocation at runtime for position independent code to changing the normal sequence of execution of instruction. For branch type instruction, since it directly updates the program counter. Index addressing mode and its application for array implementation of array addressing for record implementation. Base register addressing mode and its applications for writing relocationable code for relocation of program in memory even at runtime. For handling recursive procedures. Auto increment addressing mode for implementing loops, and also auto decrement addressing mode for implementing loops, for stepping through arrays in a loop, for implementing a stack as a push and pop. So thanking you for giving me this opportunity.